Okay, good day. This is Math 140 College Algebra. I am Professor McCulley, and this is lesson 7-2, the presentation on properties of logarithms. Let's get right to it. So today we are going to simplify and evaluate expressions using properties of logarithms, and then we are going to solve logarithmic equations using properties of logarithms. So what are those properties of logarithms? Here they are. If I have a logarithm that is a product of two values, I am allowed to rewrite that expression as a sum of two logarithms of the same base, whatever that is. If I have a logarithm that is the quotient of two values, I am allowed to expand that and write it as a difference of those two values of logarithms of the same base. And then lastly, if I have a logarithm of an exponential, I am allowed to take the exponent and bring that value down in front of that logarithm. And this one right here, this is the one. If you had one thing that you put into your long-term memory for logarithms that'll be useful, it's going to be that property number 3 because it does a lot of things for us. It allows us to solve for exponents that are variables, and it also allows us to create what is known as the change of base formula, which will allow us to evaluate using our calculator any logarithm of any base. So what does that mean? So we're going to use property 3 to derive the change of base formula. So if I ask, and so just to kind of step back and get a general idea of what we're about to do, if I asked you to find, let's use the right tool because if I don't, if I said find log of 4, well, I could do that. I could go to my graphic calculator. I could open my screen a little bit. I could go log 4 and hit enter. All right. Similarly, I could do the natural logarithm of 4 and hit enter. But those are known bases. All right. So this thing, remember, log is really log base 10 of 4. So what happens in H there when you are asked to solve log base 3 of 4. Well, what do I do with that? That's a little bit more challenging. So we're going to come up with a formula that allows us to do that in general. Okay, so what's that going to look like? Well, let's get rid of this and say, all right, I want to evaluate log base A of B. All right, so I don't know what that is. I want to evaluate that thing. All right, so let's say for a moment that this thing is equal to y, and we want to change this to exponential form. Now, that is a process that we learned in the last lesson, so that shouldn't be too hard. A to the y equals to b, and now I can take that thing, and now I take a known K-N-O-W. It's a good thing they pay me to teach math and not spelling. And remember, I said known logarithm. You know two logarithms. You know log base 10 and ln. So we can do that. So I'm going to call my known logarithm log base c. So I'm going to go log base c of a to the y equals log base c of b. All right. And now I can use that third property, property 3, log base a of x to the n yields n log base a of x. I'm going to bring this y down. So I have y times log base c of a equals log base c of b. And then I can divide by log base c of a. Now, since log base c of a is a known logarithm, this would be something that I could type into my calculator. And so it's just a numerical value. So y equals log base c of b over log base c of a. All right. Now, since these two y's are the same value, we can make a final conclusion that log base a of b is equal to log, oops, let's get a proper thing, log base c of b over log base c of a, where log base c is a known logarithm. All right, and we know two logarithms, so it could be either ln or just common log. And that is our change of base formula. All right, log base a of x is just ln of a over x, or ln of x over ln of a. It could be log of a, x over log of a, or it could be any other known logarithm. You're really only going to use these two, but this is a true statement as long as you know what log base b is. And so what that allows us to do is that it now allows us to solve any logarithm that we want to figure out. We could go the ln of 13, and as long as I need to make sure you close that parenthesis, divided by the ln of 4 is what I think that was in the last one. So I'm going to go, this thing is the ln of 14 over the ln of 3. Oh, I just totally screwed that up. Dyslexic old man. Of 3, close your parentheses, and we're done. We get the 2.4. Now, again, I said it doesn't matter what known logarithm that you use, it still works. So if I hit log of 14 divided by the log of 3, you hit enter, and again, you get the same number. So in most instances, I'm going to use ln, not because it's any better than the other one, it's just it's one less letter that I have to write. So that is going to be 2.402, excuse me. All right. Now there is a graphing calculator that does log bases, and you could look that up if you wanted to, but just as easy. All right. Rewrite the natural logarithm in terms of 3 and 5. So 75, let's talk about 75 here. Well, 75 is equal to 3 times 25, which is equal to 3 times 5 times 5. So they want us to take this 75 here and rewrite it in terms of just ln of 3 and ln of 5. So we are, this should be a times there, sorry about that. We are going to use the properties of logarithms that have a multiplication here and rewrite this as a sum. All right, so the ln of 75 is the same as the ln of 3 times 5 times 5. So we're factoring to 3s and 5s. And then we're going to expand using log base a of uv equals log base a of u plus log base a of v. And we're going to rewrite this as the ln of 3 plus the ln of 5 plus the ln of 5. I can expand that even further for every multiplication that I have in here. And now my final answer only has ln of 3 and ln of 5 in it. That looks like a good final solution. Use the properties of logarithms to expand the expression as a sum, different, and constant multiple of logarithms. That's essentially what we did in the last one. We have this division here, but we also have two exponents. Remember, square root can be rewritten as a rational exponent. So I'm going to do that first. So recall square root y is y to the 1/2. Okay. So I've got log base 4 of x squared over y to the 1/2. All right, and so I'm going to use log base a of u over v equals log base a of u minus log base a of v. Sorry, I got a cough this morning. I don't know what's up. And rewrite this thing, log base 4 of x squared minus log base 4 of y to the 1/2. And then I'm going to use log base a of x to the n is n log base a of x to bring these exponents down. And that gives me the constant multiple of a logarithm. So I have 2 log base 4 of x minus 1/2 log base 4 of y. And that is going to be my final answer there. Okay. Down to the last one here. Okay, use properties of logarithms to condense the expression into a single logarithm. So I'm essentially doing the opposite of what I did in the last one. In the last one, I expanded. In this one, I'm going to condense. So my final answer, I can only have an ln. Now I want to use, because it's a plus, I want to multiply these two things together. But I have to first move the 3 up is using log ax to the n equals n log base a of x. So since this is a property, it has to go left and right. So I have a value that is a constant multiple right now, and I'm going to do this in reverse and move that exponent up. So my first step is going to be the ln of x plus the ln of y to the third, and then to finish, I'm going to use ln, or now let's use the general form, log base a of uv equals log base a of u plus log base a of v. And again, I can, since it's a property, I can go both ways. I have a sum. I'm going to turn it into a product and write my final answer, the ln of x y to the third. And that is a single logarithm with everything in it. Put a box around that. We're done. And here is the awesome yet sad Marvel fun fact of the day. This is Kevin Feige. He was hired by Marvel in 1998 when the first Blade movie was released. In 2007, he was made president of Marvel Studios and now is the CEO and chief creative officer of all things Marvel. In 2020, he is 46 years old. In 2020, Mr. McCulley is 48 years old and will be 49 by the end of the year. And this guy is a multimillionaire, and he started with Marvel in the same year that I started with Coshocton High School. I think he's made a few more dollars than I have. Well, that's all I got for today, folks. Have a good day.